Hello students, I'm here at Ninemile Creek just outside of Wallace, Idaho with Steve Clayton. Steve is an engineer for Jacobs and he works on river restoration projects, and he's here to tell us a little bit about some of the work that's been done here in the Silver Valley to remediate areas that have been affected by tailings with their heavy metals.
Hi, thanks for the opportunity to share with your class. I haven't been involved personally with any of these projects. I have worked on projects in the lower basin, Coeur d'Alene, from Catawba to Harrison. But the two drainages, this one 9 Mile, and then an adjacent drainage, Canyon Creek here in the upper watershed, have been identified as two of the largest polluters, or the two most contaminated tributaries to the South Fork of the Coeur d'Alene River because of historic mining activity. There's a lot of groups working together to improve the condition of this watershed, including the U.S. Environmental Protection Agency, the State of Idaho Department of Environmental Quality, the Nez Perce Tribe, many of the local counties, and others as well, including a trust fund that was established following a lawsuit between EPA and the mining companies. That's the money that's being used to fund a lot of this work. The channel that we're looking at right here, you can see, has some riprap along both banks, and that's basically to try and straighten the channel here. I'm not familiar with the details of this site, but in a lot of these remediation sites, the contaminated material could either be excavated away and moved to a central repository elsewhere in the valley, or sometimes pulled up away from the river channel itself and then basically separated from surface water interaction with material like this riprap, and then this sedges, the green grasses that you see there at the toe. This particular reach of channel, you can see the yellow monitoring wells in the background, and we'll look downstream here in a second to see a little bit more of the remediation work.
Okay, let's take a look across 9 Mile Road, and we'll take a look at, after this car passes, we'll take a look at some of the monitoring wells and what they've done to the stream on this side here. All right, what are we seeing, Steve?
So from this side of the road, all we did was walk across the road. So we're at the downstream end of the culvert. One of the first things that I notice is the absence of the riprap locking that channel into a straight path like what was on the upstream side. That's probably because at this location there's a little bit more space to work with, and you can see some different instrumentation and monitoring here. A little ways down there's a white gauge in the channel. That's called a staff gauge, and that's usually used to measure the water surface elevation, basically how deep is the water, and then that'll be used in conjunction with the stream flow measurement, or the discharge, to basically track the change in the volume of water flowing through this area through time. And then there's more of the yellow monitoring wells. These are monitoring the groundwater condition here. So in this case, it's probably trying to see if the remediation work has helped to reduce the amount of contamination in the groundwater. Also, on a project like this, wood structures will be used. There's both remediation, which is cleaning up contaminated areas, and then restoration, which typically happens after remediation. And so restoration work would typically be used to try and make the habitat better for fish, amphibians, and wildlife. So in here, off to the left side of the channel, I see a wood structure that could have been tucked in there to provide cover for fish to hide up underneath there. And then downstream, there's some scattered pieces of old stumps that those or pieces similar to that typically would get placed in the channel to provide what they call large woody material that would be used to provide some habitat cover for fish and other species as well.
So Steve, why is it so important that they stabilize the banks of the river in stretches like this? Why are they having structures like riprap or woody debris or vegetation plantings to keep the rocks just in place?
So that's a great question. Any stream channel has a lot of energy as it works its way down, and the physical processes that are interacting there basically try to use that energy or the energy is dispensed as the stream moves down. So sometimes you'll see like a river that has a head cut or it's incised, or a river that has a lot of erosion, sideways, lateral erosion they'll call that. So in a channel that's nice and steep like this, there's a lot of energy moving in the down valley, the downstream direction. And so as you noted, there's been rock placed in here as well. And that's both to provide some habitat, but mostly to dissipate the energy of the river in order to try and keep it from eroding. If you were in a situation where the river was more meandering or lots of curves back and forth, that would typically be in a flatter, or they say lower gradient setting, and you'd find that in more of a meadow as opposed to this little steep reach.
Okay. Well, thank you so much. It's great to see a project like this that's working to keep those heavy metals that are present in this system, keep them in place, keep them out of the water, and help to protect the water quality further downstream, as this whole area is going to drain into Lake Coeur d'Alene. And then, of course, Lake Coeur d'Alene will drain into the Spokane River. And we'll take a little bit of time later to talk about the Spokane River and heavy metals that are present there, and how you can avoid coming in contact with those heavy metals, and then what's being done to protect the public from the presence of heavy metals in the Spokane River. Thanks so much, Steve.
You're welcome. Thanks for the opportunity.